Hello again everyone, welcome back to ptet.chemistry channel. This is the start of this section B topical MCQs on 10.4, which is just my classification for alcohols. So with these last 10 questions in the section B of the Cambridge International Paper 1 A-Level, which is a multiple choice component paper. So option A, it refers to where 1, 2 and 3 are relevant to what they're asking. If 1 and 2 are relevant to what they're asking, there is B. 2 and 3 there is C, and if only 1 is relevant to whatever they're asking, that is option D. Okay, so by logic we always check for number 2 first. Okay, these kind of questions are getting more and more popular in the other examination body as well, because they do test more than one concept in one go. Yeah, so this one is asking you which alcohols, when you oxidize it with acidified, because you always need the acid for the dichromate 6 to work. Oops, sorry, there's no charge because I'm using potassium there. Give an organic product which causes an effervescence when you react with sodium carbonate. So we need to produce an acid. We need to produce a carboxylic acid, because a ketone or an aldehyde will not react with sodium carbonate. You need a carboxylic acid which is acidic. Alright, so the acid will react with sodium carbonate. So a lot of students don't know how to write the balance equation. Yeah, you do get carbon dioxide and water. The fizziness, the effervescence is due to the CO2. But then your salt is going to be the carboxylate. So that is the Na plus and RCO2 minus. When you give away the H plus, you have 2 sodium there. So I need 2 of these. If I have 2 of these, I have 2 of the acid. And 2 of the H plus give me the H2. 1 of the oxygen, they give me the O. They give me the CO2. 2 sodium goes there. This equation is nice and balanced. Alright. But a lot of students, they would have written the equation without balancing it. They will have run into trouble when they try to do calculation question with it. So the idea to produce a carboxylic acid when you oxidize it is you need a primary alcohol. Primary alcohol means that the carbon with the OH is bonded to one other carbon. So if we check that, it's really a test on naming. Propane 1O. So there's OH, there's 1, 2 and 3. I'm drawing skeletal because that is faster. 2 methyl. The carbon with the OH is bonded to one other carbon. Okay, so this is a primary alcohol. Number 2 is correct. Okay, I mean it can be oxidized to give you a carboxylic acid. Therefore, it can effervescence with sodium carbonate. Butane 1O, 1, 2, 3, 4. Well, I can see the carbon with the OH is bonded to one other carbon. This is primary alcohol as well. Number 3 is propane 2O, 1, 2, 3. So that is propane 2O, so 3 carbon, OH at position 2, and then 2 methyl. So this is actually a tertiary alcohol, because the carbon with the OH is bonded to 1, 2 and 3 other carbon. This cannot be oxidized at all because there's no hydrogen on this carbon with the OH to be lost. If you can't lose the hydrogen on the carbon with the OH, well, you can't oxidize it at all. Alright, so tertiary alcohol are not oxidized at all. Therefore, it won't even give you the carboxylic acid. 1 and 2 are correct. That's option B. Moving on to the next one. It says which ions are present in a solution of ethanol in an excess of concentrated sulfuric acid. So concentrated sulfuric acid, that can be a strong acid. So sulfuric acid can do many things. Yeah? It can be a oxidizing agent, well, with the halogens, okay, but not chlorine, only from bromine, iodine, etc. onwards. But we know it's a weaker oxidizing agent than chlorine. These are part of your group 17 chemistry, very, very popular. Yeah, but we also know it as a dehydrating agent, and it is the third function here that is important in the case of ethanol. All right, so when you have CH, if I draw out the display, which you don't see me doing very often, okay, so this is the place with the OH. Oops, nope, I don't want that. I want that. Okay, this is the place with the OH, and the thing is, when you dehydrate it, you would get a double bond there, and you can remove any of this hydrogen. Then you can get like that, right? yeah, and then plus H2O. But what are they asking? So when you have corn sulfuric acid, you have H2SO4 in water. Okay, now you have ethanol. When you mix this and this together, what's gonna happen is, well, that thing there can definitely pick up an acid. There's no problem at all. It can pick up the H plus from the acid, as a result, strong acid. In fact, that is probably how it promotes the elimination to give you the double bond eventually. So number 2 is definitely correct. This can definitely pick up an acid, and you can get CH3, CH2OH like that, and that become 107 degree, and that is a very common oxonium ion. You have done this in acid-base chemistry. As for the first one, that involve deprotonating alcohol. And what we know about alcohol is not acidic. Okay, to get to this, you need sodium. You need sodium metal, or you need potassium metal. Then you can get the alkoxide plus the hydrogen gas, like ROH plus sodium will give you RO minus, like that. And a lot of students would have struggled to balance the equation because they forgot that you also give hydrogen gas, which means you need half of it. So 1 mole of it give you only half mole of H2 for 1 OH group. You don't get that with an acid, you get that with a metal. You don't get that with sodium hydroxide because alcohol is not acidic. Okay, I can tell 1 is wrong because this is an acid. 2 is correct, 1 is wrong. There can only be one option. Okay, and you can get HSO4 minus because, well, you know, you have a strong acid, right? So the H2SO4 can dissolve to give you the acid. That's the first dissociation. It's fully dissociated in water because you also have water when you have corn sulfuric acid. Okay, and therefore you can have some of these when you have a solution of ethanol. And one thing is a solution of ethanol. So this is ethanol in water. They don't say ethanol, they say a solution of ethanol. Just like your hand sanitizer, it's ethanol dissolved in something dissolved in ethanol. Okay, so 2 and 3 are correct. That's option C. Moving on to the next question. Okay, so this overlap a little bit with carbonyl chemistry, yeah, because they have talked about Phalanx reagent. This is a test for aldehyde, which you will see in the next subtopic on carbonyl compound, aldehyde and ketones. So Phalanx reagent consists of copper 2 plus. I will not go into detail, okay, into this, but this is a blue solution. This is a pale blue solution. Actually, it contains something else. It's not just copper 2 plus in water. It's got something else as well. When you test for aldehyde, the aldehyde will get oxidized to a carboxylate. It's not a carboxylic acid, to a carboxylate, because you're actually under alkaline environment. Okay, and then you will get copper 1 oxide. So now you have copper plus and O2 minus. There will be copper 2 oxide. That is your brick red PPT. You have done this in biology, something like a food test for carbohydrate, okay, or sugars. Okay, sugars, aldehydes are actually components of reducing sugar. So test for reducing sugar using the blue solution. They call it Benedict solution, and then you get the brick red PPT, which is actually copper 1 oxide. Copper 1 oxide, people always get the formula wrong because it's actually copper 1 and oxide. Okay. Anyway, so if we want to get the aldehyde, the most important thing is we want the aldehyde. So we need primary alcohol, because only primary alcohol can give you the aldehyde, right? Not the secondary alcohol, which will give you ketone, not the tertiary alcohol, which will not be oxidized. So again, we need to identify. If we look at 2, so there's OH 1, 2, and 3. So this is just called propane 1-ol. Yes, that is primary alcohol. The carbon with the OH is bonded to one other carbon. If I check number 1, So there's 1, 2, and 3. This is propane 2O. This is a secondary alcohol because the carbon with the OH is bonded to 2 other carbon. This is a secondary alcohol. It will not give you aldehyde. 2 is correct, 1 is wrong. There's only one option. In fact, you can tell that it's just methanol. The carbon with the OH, well, methanol can be oxidized because it's not bonded to any other carbon. It's like the simplest alcohol of all, okay? Methanol. I mean, that can be oxidized partially. If you want to stop at the aldehyde, that can happen. So this is called methanol, which is a 1-carbon aldehyde. This is called propanol, which is a 3-carbon aldehyde. Both aldehyde will react with phalanx. They can be oxidized, and the copper 2 become copper 1. When the aldehyde get oxidized, the copper 2 get reduced, decrease in oxidation number, okay? Moving on to the next question. So they say mevalonic acid is an intermediate in the biosynthesis of cholesterol. So what properties does it have? Okay, if you check number 2 first, it can be esterified both by ethanol acid and ethanol. In the presence of that, so you need a H2SO4 catalyst, you need a corn sulfuric acid catalyst. Well, if I show you, it's got the alcohol bit, okay? So those bits can esterify with ethanoic acid. You can do condensation, right, between the acid and the alcohol. And then, of course, you can also do, that is a carboxylic acid. That one is can esterify with ethanol because that is the carboxylic end, so they can undergo condensation with ethanol. So 2 is correct because it has got both carboxylic acid and alcohol group, okay? If I check number 1, it has, well, this is about chiral carbon. So if I look at that, that cannot be chiral. That is a CH2, cannot be chiral, cannot be chiral, cannot be chiral, cannot be chiral. And this thing there in the middle, this is the chiral carbon. That is the only one. Only one is correct. That is the only one in the middle there. This is a CH2 with carboxylic acid. This is a CH2 with alcohol, alright? And then next bit, it contains both primary and secondary alcohol. So this carbon with the OH is bonded to 1, 2, and 3 other carbon. So that is, I don't mean to say that. I mean to say this thing is a tertiary alcohol because the carbon with the OH is bonded to 1, 2, and 3 other carbon. This, on the other hand, the carbon with the OH is bonded to 1 other carbon. This is a primary alcohol. So secondary is wrong. It should be tertiary. So it has a primary, yes, but it doesn't have a secondary. It has a tertiary alcohol. 1 and 2 are correct. That is option B. This is the last question of this 5-question series of this topical MCQ. So what can you produce when you have butane 1-ol? 1, 2, 3, so I'm missing 1 carbon. Dilute acidified KMnO4. So you have H plus and KMnO4. You would have known by now that is an oxidizing agent. So what can you produce? They say what can be produced. They don't tell you whether you distill it to get the aldehyde or whether you reflux it to get a carboxylic acid, but what can you produce, all right? So you can oxidize all the way and get carboxylic acid. So that is a 4-carbon carboxylic acid, so that's butanoic acid. You can heat and distill immediately because this thing is the aldehyde. It's a 4-carbon aldehyde. It's called butanol. It has a lower boiling point than the alcohol because it cannot form hydrogen bond between the molecules because there's no hydrogen bonded to the oxygen. Okay, so it just has permanent dipoles between the molecules. So you can get butanol. What you cannot get is you cannot get butanol because to get butanol, you need a secondary alcohol. You need a secondary alcohol because that is a carbon with the OH is bonded to 2 other carbon. There's 1 hydrogen there. Only then you can oxidize that to the ketone, which is butanol. So you can't get that with butane 1-ol, which is a primary alcohol. The carbon with the OH is bonded to 1 other carbon only. So 1 and 2 are correct. That is option B. This is the end of this 5-question series. If you enjoyed these tutorials, please subscribe to the channel. Please share the words about the channel to your friends, your class group chat, your juniors, your seniors in school, those who are about to enter 6th form very soon, I guess, and anyone else you know who might benefit from this channel. Okay, thank you for watching. I'll catch you in the next video.